Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're going to be looking at Unit 2 on congruence. This is Lesson 7, the angle, side, angle, triangle congruence. The learning goal in this lesson, let's see if we can prove other sets of measurements that guarantee triangles are congruent and apply those theorems. We have two learning targets in this lesson. Number one, I can explain why the angle, side, angle, triangle congruence theorem works. And number two, I can use the angle, side, angle, triangle congruence theorem in a proof. For glossary terms, our first one is auxiliary line, an extra line drawn in a figure to reveal hidden structure. For example, the line shown in the isosceles triangle is a line of symmetry, and the lines shown in the parallelogram suggest a way of rearranging it into a rectangle. Next, we have corresponding. For a rigid transformation that takes one figure onto another, a part of the first figure and its image in the second figure are called corresponding parts. We also talk about corresponding parts when we are trying to prove two figures are congruent and set up a correspondence between the parts to see if the parts are congruent. In the figure, segment AB corresponds to segment DE, and angle BCA corresponds to angle EFD. Our last glossary term is parallelogram, a quadrilateral in which pairs of opposite sides are parallel. Now that we're done with the introduction, let's take a look at a few practice problems.
Here we go, folks. We've got a real barn burner of a math problem on our hands today. Let's see how this equation plays out.
So practice problem number 1 says, what triangle congruence theorem could you use to prove triangle ADE is congruent to triangle CBE? Well, I'm going to assume that based on the name of the lesson, you can figure out that we are trying to use the angle, side, angle congruence theorem. So the important thing here is to understand why. So they give us a couple pieces of information in the diagram. First off, they let us know that angle A is congruent to angle C. That's what this single tick mark on the angle arc is telling us. Now next, they show us, based on this tick mark right here in the middle, that line segment AE is congruent to line segment CE. And so we have our angle and we have our side. So the next thing we need is the other angle. And what we have here is that we have this line AC being divided in half by this line DB. And so when I have two straight lines transecting each other, then the opposite angles are going to be congruent because those lines are splitting each other. So now I know that angle A is congruent to angle C. Side AE is congruent to side CE. And angle E is congruent to angle E. Or angle DEA is congruent to angle BEC. So now that I have angle, side, angle, that's my answer. So angle, side, angle, congruence theorem. And the reason that this works is that if I know I have side AE and I know what angle A and E should be at, then I know that these two sides are going to have to converge at point D. And so when I take this triangle on the left and I rotate it into position where this blue angle lines up with this blue angle, this green side lines up with this green side, and this yellow angle lines up with this yellow angle, then the same exact thing is going to happen. This line must intersect this line at B, and B and D are going to be congruent to each other. Therefore, the triangles will be congruent to each other. I hope this makes sense, but if you have any questions, please leave a comment below.
I'm once again asking you to solve this equation, and don't tell me we can't afford to get to the answer.
Practice problem number 2 says Vaughn wrote a proof that triangle BCD is congruent to triangle DAB. Vaughn's proof is incomplete. How can Vaughn fix his proof? So his first statement is that line AB is parallel to line DC. That's indicated by these arrows at the top and bottom. And cut by transversal DB, this diagonal line going from the top left to the bottom right. Therefore, angles CDB, so CDB is this angle right here, and ABD, this angle right here, are alternate interior angles and must be congruent. So these angles are the same in blue. The next statement is that side DB is congruent to side BD because they are the same segment. So we're talking about this side right here. So now we have an angle and we have a side. Next statement is that angle A is congruent to angle C because they are both right angles. So we're talking about this right angle and this right angle. He goes on to state, by the angle-side-angle triangle congruence theorem, triangle BCD is congruent to triangle DAB. The problem is that while he has two angles and a side, it is not the side between the two angles. Therefore, we need to prove that angle ADB is congruent to angle CBD. And we can do that by the triangle angle sum theorem. All three interior angles on a triangle must add up to 180. So if we already know that two angles are the same, then the third angle must also be the same. So the statement that needs to be made, we would put right in here, due to the triangle interior angle sum theorem, angle ADB is congruent to angle CBD. Now, the next statement is correct. By the angle-side-angle triangle congruence theorem, triangle BCD is congruent to triangle DAB because now the side that we have proven congruent has the angles on each end of that side proven to be congruent. So the important thing to take away from this problem is that it can't just be any two angles and any side. It must be the two angles on each end of the side. The side has to be in the middle like a sandwich, and the angles have to be the bread on the ends of that sandwich. I hope this helps you understand this problem, but as always, if you do have any questions, please leave a comment below.
We're going to solve this problem not because it's easy, but because we need to get to Mars.
Practice problem number 3 says that segment GE is an angle bisector of both angle HEF and angle FGH. Prove triangle HGE is congruent to triangle FGE. So the first thing, obviously because of the title of the unit, we are trying to identify angle-side-angle congruence to do this proof. So the first thing that sticks out to me right away is that segment EG is congruent to segment EG because it is the same line. So EG is congruent to EG because they are the same line. So I have my side. Now I need my angles. Well, they tell us that segment EG is the angle bisector of HEF, which means that angle HEG is congruent to angle FEG because of the definition of angle bisector. Now we need one more angle. And specifically, we need it to be the angle on the other end of the side that we have. And they tell us that segment EG is the bisector, angle bisector of FGH, which means angle FGE is congruent to angle GE or HGE because of the definition of angle bisector. So now we can make the final statement of our proof. We can prove that triangle HGE is congruent to triangle FGE because of the angle, side, angle, triangle, congruence theorem. So this is how we write a proof. We proved that the side was congruent. We proved that the angle on each end of that line segment was congruent. So therefore we can make the statement that the two triangles are congruent because of the angle, side, angle, triangle congruence theorem. I hope this helps you understand how to write these proofs. But if you do have any questions left, please go ahead and leave a comment below. So just to make sure you understand everything you need to coming out of this lesson before you go into the next, we want to look back at our learning targets. Number 1, said that you can explain why the angle, side, angle, triangle congruence theorem works. And there's a couple of explanations I can give you here. Number one, if I know that I've got a side on each triangle that is the same size, they're congruent, and then I know that the angle I'm going to draw the next line on both ends of that line are congruent, then when I draw those next lines at those given angles, there's no other possibility than for those two lines to meet each other at the same point. So that's one explanation of why this works. The other explanation is that if I have two triangles and I know that I've identified one side on each triangle that are congruent, and now I have identified that the angles on each end of that line segment are also congruent, then I know that there is some combination of rigid transformations that can move one of those triangles onto the other triangle to where that side and those angles on each end of it are going to lay right on top of each other. And when I line them up like that, I know that the rest of the triangle is going to lay on top of each other as well. So the fact that there is a series of rigid transformations, once I have that angle side angle, that will let one triangle lay directly on top of the other one, tells me that those triangles are congruent. So whichever way makes more sense to you, go ahead and think of it that way, but both are different explanations for why this works. And then learning target number 2, I can use the angle side angle triangle congruence theorem in a proof. Well, that's what we did there on practice problem number 3. We proved that we had a side that was congruent. We proved that the angle on each end of that line segment were congruent. And therefore, our final statement is that because of the angle side angle triangle congruence theorem, it proves that the two triangles themselves are congruent. So when you're writing that proof, your steps are to write the statements for how you're proving that you do have a side that's congruent and that you specifically have the two angles on each end of that line segment that are congruent. And once you've made those 3 statements proving that you do in fact have angle side angle congruence, you can then make that final statement that that specific congruence theorem proves the triangles are congruent. I hope all of this from lesson 7 has made sense. If you do still have any questions, please leave a comment below. If you do find these videos helpful, please give this one a thumbs up. In the bottom left of the screen, you should see a video that YouTube thinks you will also find helpful. And then in the bottom right of the screen, you should see the subscription button for the channel. It really helps out. I look forward to seeing you in the next video.